Hello, this is Philip and welcome to my channel for this new episode of kOS. This is the last episode for my full mission 3. In the last episode I show you how to change your next patch orbits, okay, if you are in the transition between Kerbin and the Moon, in transfer orbit between Kerbin and the Moon. You can change during this transfer, you can change the periapsis and the inclination of your future orbit around the Moon with a small cost. Okay, so we talk about this in the last episode, and today I want to show you how I did my transfer, how I put my maneuver node in the exact position to go to my to the Moon. Okay, so for that you don't need to understand a lot of kOS. You just need to learn how it works in KSP and with the orbits, and more importantly I'm talking about angles, and you have to understand which angles I'm talking about. So for that I prepared a little graphic to show you all of this. In this picture you can see Kerbin here. This is the orbit of the Moon, so the Moon is here, and this is the orbit I want for my craft. Okay, so I want my craft to be here, to execute the maneuver node, okay, to burn prograde until the apoapsis reaches the Moon's orbit. Okay, and I have to do that at the right moment, because if I do my burn too late, my craft has some time to go from its periapsis to its apoapsis, and during that time, okay, the Moon is moving too. Okay, so if my burn is not at the right moment, okay, my craft will miss the Moon. Okay, so, and if I burn too soon, okay, this will be the opposite. My craft will reach its apoapsis before the Moon reaches the same point. Okay, so for that you have to calculate the time your craft needs from its periapsis to its apoapsis, and this is a simple one, because when you have the characteristics of your orbit, when you know the periapsis and the apoapsis, you are able to calculate the period of your orbit. And from the periapsis to the apoapsis, this is the half of the period. Okay, so when you know the periapsis and you know the apoapsis, you know the whole period, and so you know the half period. So you know how much time your craft needs to go from its periapsis to the Moon's orbit. Okay, and you also know the time of the period of the Moon's orbit, and you know the velocity of the Moon. So you are able to calculate the distance, okay, from that point to the apoapsis. For example, here, let's say my craft needs 3 hours to go from that point to that point. I know that the Moon is the velocity. I know the velocity of the Moon, so I'm able to calculate which distance the Moon's. I don't have the verb, sorry, but what is the distance for the Moon in 3 hours? Okay. And then I am able to calculate the angle here I want. So this is the distance, okay, and with that distance it's some proportionality, okay, so the total angle is 360 degrees. Okay, and I know the length of the orbit because the moon has a circular orbit. So I can divide that distance by the distance of the circumference of the orbit, and I have a coefficient, and then I multiply that coefficient by 360 and I have the angle. Okay, so this is the angle for the moon, right? And I want to know, okay, so during that time, this is the angle from the moon, and I need to know the angle from the craft to the moon with Kerbin at the center. Okay, so I want to know the angle craft Kerbin moon, all right, when my craft is at that point. So I know the angle moon Kerbin apoapsis. Okay, so I'm able to calculate that angle. So it's easy to calculate the angle craft Kerbin moon, because the angle craft Kerbin apoapsis is 180 degrees. Okay, so if I subtract the angle moon Kerbin apoapsis, I have access to the angle moon Kerbin craft. Okay, the question is how can I have the angle, those angles, how can I use kOS and KSP to calculate those angles? In this new picture I have Kerbal, okay, the sun, Kerbin, and at the very beginning of a new game the vernal direction is defined with the center of mass of Kerbal and the center of mass of Kerbin. This direction is defined once at the beginning of the game, and then it doesn't change. Okay, so Kerbin will orbit around Kerbal. The vernal direction doesn't change. Okay, with that vernal direction, and for any orbit you have the ascending node. The ascending node is defined using the vernal direction. Okay, so for one given orbit you can define the longitude of the ascending node. This is the angle between the ascending node, Kerbin, and the center of mass of Kerbal. Okay, so this is the angle with the vernal direction. All right, so if your ascending node changes, the longitude is not the same. Okay, then for any orbit you have a periapsis. Okay, and that periapsis is defined with the ascending node. Okay, so this is called the argument of the periapsis. Right, so the argument of the periapsis is the angle between the periapsis, the center of mass of Kerbin, or any body you are orbiting, and the ascending node. Right, and then you have a craft here around in the orbit around Kerbin. Okay, and the position of the craft is defined with the periapsis. Okay, and this is the true anomaly. Okay, so the true anomaly is the angle between periapsis, Kerbin, and the craft. This is the same, for example, Duna and Ike. Okay, Ike is orbiting around Duna, so the true anomaly is the angle between the periapsis of Ike's orbit, Duna, and Ike. Okay, so doing this, you can calculate the angle of the craft, but in terms of that vernal direction, because the vernal direction doesn't change. This can be your reference, okay, and you can calculate the angle with that reference, and for that you just have to add the longitude of the ascending node, the argument of the periapsis, and the true anomaly. Okay, and that angle can be above 360 degrees if you add the three angles together. Okay, so you have, if this is the case, you just have to subtract 360 degrees to get your angle here. Okay, so this is it. This is your angle from the reference here, the vernal direction of your craft. And you can calculate the angle of your craft like that. You can calculate the angle, for example, of the moon. And doing that, you can subtract the two angles to know the angle between your craft and the moon. Okay, so this will be useful here, because in this situation, as said, you can calculate 180 degrees minus the angle here on the moon, Kerbin, and the apoapsis. But this works only when the craft is here. But if the craft is here, how can I calculate the angle with the moon? For that, it's better to use that method. You calculate the angle of your craft using the vernal direction, the angle of the moon using the vernal direction. Okay, and you can have access at the angle between the craft and the moon at any moment. Okay, and you want that angle to be equal to the angle calculated here with 180 degrees minus that angle. Okay, I hope I was clear with those explanations, because I'm using that in my script. So when you are writing difficult scripts, some complex scripts, sometimes the problem is not kOS, the problem is the math or the physics behind the script. Okay, and this is the script. So first I set my target to the target body. Okay, so in my case my target body is the moon. Okay, but you can change for Minmus. That transfer to body is only a transfer inside the same SOI. Okay, don't expect to use that transfer function to go from Kerbin to Duna, for example. No, it's good from Kerbin to the moon, or from Kerbin to Minmus. That's all, or from Duna to Hike, for example, but not from Minmus to the moon. I didn't try this. Maybe it can work, but I'm not sure. I'm not sure. Okay, so first my target body is the moon. Okay, and I can do my do warp. I can say it's false or true. Here I let the default value, so the do warp is false. Okay, and the do warp is just here to warp until the transition from Kerbin to Minmus plus 120 seconds. That means 2 minutes after you reach the orbit around the moon. Okay, but here I don't want to warp to that orbit around the moon, because after my transfer I want to change the periapsis and the inclination. Okay, like we saw in the last episode. So first I say, okay, the target angle is 180 minus the compute target angle. So we saw that in my graphics. Okay, I want the angle between the ship and the moon. Okay, so for that I need to look at my compute target angle. Okay, from the moon. We'll see what is that function, and I take that from 180. So let's look at this function here, target angle. So it is very simple. Okay, I look at my I say, okay, my periapsis is the my ship apoapsis. It's the moment where I will burn. Okay, I did that because I suppose my parking orbit is circular. If it's not quite circular, it still works, but it will be less precise. But I don't care, because I want to change the orbit after that, so it doesn't matter. If my orbit, my first orbit, was too elliptical, it could be a problem. Okay, the semi-major axis is calculated with that formula. Okay, so the periapsis plus my apoapsis, and also here because the Mun has a circular orbit. This is why it works. Okay, and the Minmus is the same. This is a circular orbit, so you can use that. If Minmus was in a very elliptical orbit, you can't do that. But okay, because there are circles, it's easier for us. So I calculate the semi-period, so I don't want the complete period of my orbit, just the semi-period, and I want to know the time, so my ship needs from its periapsis to its new apoapsis, okay? And then I look at my target period, and this is great because kOS can look at the files from KSP, and you don't have to calculate that. You have directly access to the orbit period of each body of KSP. And then you just do your proportionality here. Okay, so my semi-period multiplied by 360 divided by the target body period. So this is the angle I need, the Mun needs to go from its actual position to encounter the position of my ship. Okay, so this is the target angle. So this is the moment when the Mun reached that angle. I want to start my burn at that moment. And then I lock the phase angle to compute phase angle. This is a lock because each time I'll use phase angle, it will be calculated again and again. This is the angle between the Mun and my ship. And at any point, this is the angle between the Mun and the ship at the moment I want my maneuver. Okay, so there is only one moment for that, and this is the angle computed in real time. Okay, so the compute phase angle, I just need to compute the vernal angle of my ship and the vernal angle of the target angle. Okay, and with that, if I was clear in my previous explanation, to get the vernal angle, you just need to look at the LAN of your orbit plus the argument of periapsis plus the true anomaly. Okay, and if this angle is greater than 360, you can apply that little math formula to keep your angle always between 0 and 360 degrees. It's not exactly the way kOS works, because kOS look the phase angles between negative 180 and plus 180, but it doesn't change anything because you choose your reference. Okay, my reference is the vernal angle. I choose to write that angle between 0 and 360, and if your whole script is consistent with your choice, there is no problem. Okay, that vernal angle needs a parameter. The default value is the ship. Okay, but so there is no parameter here because I want the ship's vernal angle, and here I have a parameter, and this is the Mun's phase angle. Okay, so this is the target, and in this case my target is the Mun, and this is it. Once you have that, you have all the things you want. Okay, so first, if I, for example, I don't know, for any reason, when I start the script, if my target angle and my phase angle are too close, less than 30 degrees, okay, the absolute value of the difference is less than 30 degrees, I prefer to warp little. Okay, and then I prefer to start with a bigger difference. Okay, so this is why I have sometimes on orbits, okay, to go around. Okay, so my delta angle is the difference between the target angle and the phase angle. Okay, and the delta time is the time I need to go to 1 degree of my in my orbit. Okay, so in the orbit is divided in 360 degrees. Okay, so my period, if I divide the period by 360 degrees, I have the time to 1 degree. Okay, so I look at this, and no, sorry, no, here it just, no. Okay, okay, I didn't remember that. Okay, no, that until loop is the main loop. Okay, I thought I did some another loop before, but no, this is the main loop. Okay, I'm looking at, I want my target angle to be the difference of the two angles. I want this to be less than 30 degrees. This is my main loop. Okay, so I warp until this is true, and when this is true, I calculate this, and this helps me to put correctly my angle. Okay, here I have no weight 0 or weight 1, so this is executed very quickly by kOS in one physics tick. Okay, so there is no change here of the target angle, the phase angle between that moment and that moment doesn't change. Okay, so I create the node. The delta V is computed with my Hohmann transfer because I want to start with that the ship altitude, and I want to go to the upper axis of the moon, because this is a circular orbit. The moon has a circular orbit, so I can just check for the upper axis. And to be a little safe, and if you watch the video you saw that it is not safe at all, I want to subtract the radius of the moon and to subtract 30 kilometers. But even with that, when I finished my maneuver node, my orbit was impacting the moon. Okay, but it doesn't matter, because then I can here change a little my periapsis. I can do a little burn to change my periapsis, and I want my periapsis to be greater than 10 kilometers. And this is it. So the most important part here is to understand how I compute the target angle and the phase angle, and then it's just, okay, I wait until I have the angle I want, and then I execute my maneuver, and this is it. And after that you can continue your script, and you can change the inclination and the periapsis of your orbit around the moon. Okay, I think this is all you need to know to launch a rocket around the moon and to change its periapsis and its inclination, for example, to scan the moon and to go to a polar orbit. I hope you enjoyed this mission, and I see you next week for the next mission. See you soon. Bye bye.